So today we're looking at the distance from a point to a plane in R3. So let's see. So I have written out the expression for the distance from a point to a plane in R3. So why don't we have a look at it? So we have our point P0. We have our plane pi. So plane pi. And we're looking for the perpendicular distance from the point to the plane. So this is our distance d. So this distance d is given by this following expression. So the magnitude of ax0 plus by0 plus cz0 plus d all over the square root of a squared plus b squared plus c squared. So a, b, and c from our plane, those are the coordinates of the normal to the planes. It's actually the magnitude of the normal in the denominator. And in the numerator, we just evaluate our plane, or the left-hand side of the expression for the plane, at the given point P0, and we take the absolute value of that expression. Okay, so now with that in mind, let's see what we're asked. So we're asked to find the distance between two planes. So we're given two planes, 2x minus y plus 2x plus, okay, that's a little odd. We have a bunch of x's in here. We don't have planes. Okay, so looks like we got some typos. So let's fix that up. So let's replace the z and this with a z. So we actually have a plane. Looks like we got some typos. All right, so our first plane is 2x minus y plus 2z plus 4 equals 0. Our second plane is 2x minus y plus 2z plus 16 equals 0. All right, so if you notice, looks like this part is the same in both equations. The only difference is the constant. So this means we have two planes that are parallel to each other. Let's call one pi 1 and the other plane pi 2. So these two planes are parallel. Now we need to find the distance between the two planes. So why don't we want to find this distance here? Okay. All right, so what we can do is we can find a point P0 on one plane and then apply our expression for the distance from that point to our second plane to get the distance from one plane to the other. So why don't we do this? Let's try and find a point P0 on our plane pi 1. All right, let's write out pi 1 is the plane 2x minus y plus 2z plus 4 equals 0. I'm going to look for a point on here. Let's take the point. Let's try the point. P0 equals -1, 0, -1. Now let's test it. 2 times -1 minus y plus 2 times -1 plus 4. What does that equal? -2. Whoops. Our y is 0. Let's plug 0 in for y. -2 plus 4, that equals 0. So then, yes, this is indeed a point on the plane pi 1. So now, let's make it a little smaller. Let's use our expression for the distance from a point to a plane. So d equals, now we're going to use plane 2, -1 minus 0 plus 2, -1 plus 16. So we put P0 into P2 over the magnitude of the normal to plane 2 or pi 2. Square root of 2 squared plus -1 squared plus 2 squared. Okay. So let's evaluate everything. In the numerator, we have -2 minus 2 plus 16, absolute value of this, over the square root of 4 plus 1 plus 4. This equals In the numerator, we have 12. The denominator, we have the square root of 9 or 3. So 12 over 3 is 4. So the distance between our two planes is 4 units. Whoops. Good. That wasn't too bad. Okay, so what do we have here? Okay. All right. So we're asked to find the distance between the lines L1 and L2. Okay. So it looks like we have a bit of information on how to do this problem down below. So we can look at this, or why don't we cut all of this out and work on it ourselves? See if we can figure it out. So we have 2 lines. So let's draw these 2 lines and sketch them. Line 1 and line 2. Line 1, line 2. Okay. Line 1 and line 2. So now what do we have to do? Okay. We need to find the distance between these 2 lines. So suppose we try and create a plane that contains one of the lines, say line 2. We'll call that plane pi. So we want to figure out the equation of the plane pi that contains line 2. So how do we find the equation of a plane? We need 2 direction vectors. So we want this plane pi to contain line 2 and be parallel to line 1. So find plane pi that contains line L2 and is parallel to line L1. So we need 2 directions for our plane. So we can take the direction vector for line 2, let's call that M2. And since we want it parallel to line 1, why don't we take the other direction vector to be the direction vector M1 given in line 1? So now that we have 2 direction vectors for our plane, we can find the normal to our plane. All right, so let's take M1 and M2 as the direction vectors for pi. Now let's find, it's a funny pi. Okay, so now let's find n. Normal to pi. All right, let's do this. All right, so how do we find the normal? The normal is cross product of our 2 vectors, M1 and M2. All right, so let's plug in M, our direction vector M1 is 1, 3, 0. Direction vector M2 is 0, 1, 1. Okay, so this equals I, our unit vector I times 3 minus 0 minus J, unit vector J times 1 minus 0, plus unit vector K times 1 minus 0, again. So our normal is 3I minus J plus K, or in coordinates, we have 3, -1, 1. All right. Okay, so now that we have the normal to our plane, so now pi, our plane pi equals 3x minus y plus z plus d equals 0. We need to figure out this constant d. But we know that plane pi contains line 2. whoops, contains line 2. So we know at least one point, this P, yes, let's call it P, point P lies on plane 2. All right, so since pi, plane pi contains line L2, point P equals, those are 0.010, that's a point on line 2, 0.010 lies on plane pi. So we can use this point to find D. Let's use P to find D. All right, so 3 times 0 minus 1 plus 0 plus D equals 0. So D equals 1. All right, so now, so therefore, our plane is 3x minus y plus z plus d, not d, so our d is 1 plus 1 equals 0. This is our plane. Now we can use our formula to find the distance from line 1 to line 2. Okay, so we use a different color. Why don't we? So therefore, their distance equals, so let's go back up and find our point. So our point, let's call it blue, our point P, 0 on L1, we're going to use as a 0.101. That's going to be our point P0. So we're looking for the distance now from P0 to our plane pi. All right, so let's go back up and use that. All right, so we're going to use, why don't we write it like this? Let's state it out now a little differently. So now the distance we are looking for is the distance from point P0, which is 0, sorry, was that 101 to plane pi. 3x minus y plus z plus 1 equals 0. Just want to go up quickly and check that we got the right point. Yes, P0 is 101. We've got our plane, so let's find this distance. So let's scroll over to the right so we have a bit of space. All right, so our distance equals absolute value of our point of our plane evaluated, or left-hand side of the equation of our plane evaluated at point P. We have 3 times 1 minus 0 plus 1 plus 1, absolute value equals the magnitude of our normal, which is 3 squared plus negative 1 squared plus 1 squared. So this equals, in the numerator, we have 3 plus 2, absolute value of 3 plus 2 over 9 plus 1 plus 1. In the numerator, we have 5. In the denominator, we have the absolute value of 11. So this is our distance. Therefore, the distance between lines L1 and L2 is 5 over the square root of 11. Good. All right, so that brings us to the end of our session today. Let's scroll right down. Wow, we wrote really big. All right. So if you have any questions, feel free to send us an email at info@raisemymarks.com or give us a call day or evening, and we'll be happy to answer your questions. Thank you for watching, and we will see you soon.